Okay, hello and welcome back to Physical Science Online Notes. This is our second note session for this unit. We're still in the motion unit, and BP2 is what our notes are on today, which is on how do we graph, or actually I think this should more read how do we read a graph. We're not going to be doing as much actually graphing ourselves. I'm not going to give you a bunch of data and expect you to graph it. Instead, I'm usually going to give you the graph, and then you're going to have to interpret the graph and tell me what's happening. That's more what this unit is about. That's more what this big picture learning target is about. So before we get there, hopefully you've done graphs just a ton in math class. We've been assured by the algebra teachers that you've done a lot of graphing, that you've done a lot of slopes, that you've done a lot of these three variable equations in your life. If that's not true, sign up for Flex, get some extra help, ask if that is not true. But just some general reminders here, characteristics of a good graph, some places you should look right away when you see a graph is that it should have a title. That title is going to tell you a lot about what your graph is looking at. It's going to really help you envision it, get a sense of what's going on. There should also be labels on each axis. So x-axis, y-axis, both of them should have labels with chickens, with units, in order to tell you, is it meters, is it kilometers, is it inches, what is it actually measuring? And that really helps you. So if you look, one of the first places I look at graphs, anytime I see a graph, before I even look at the shape of it, I look at the title and I look at what it's labeled with. And then I look at the data itself. Some graphs may also have a key, especially if they have multiple different lines on them. That'd be a color key or a shape key or something like that. And just a kind of sciencey thing, the independent variable always goes on the x-axis. Independent variable is what you're changing. The dependent is what you measure. That goes on the y-axis. So there's some characteristics of a good graph. Some places to look at any graph that you're given. Slope, reminder of slope, reminder of M, the famous M from math class. Slope is the rate that a graph changes. You'll often hear this said as rise over run. Real quick, as long as I got the whiteboard in the background. I know I'm kind of small, but if you have a graph here, or my pen doesn't work, a graph here. What we mean by rise is the distance that it goes up or down. And what we mean by run is the distance that it goes forward or backwards. So that's what rise and run mean. Rise divided by run, or another way to say it is change in y divided by change in x. Remember that delta symbol from before? Change in y divided by change in x. That's how we find slope of a line. You can also just kind of compare slopes without calculating them. So on a distance time graph, distance is on the y-axis, time is on the x-axis, and the slope of the line is the speed or the velocity, kind of interchangeable. I think we're going to use the word velocity because it has a positive and negative a little bit more. So that if you want to make a correction to the notes, I would say velocity. It must have all the good characteristics of a graph, and it gives us that velocity or that speed by looking at them. By looking at the slope of the line, we can determine an object's speed or velocity. That's why slope of graphs, distance time graphs, is so important. When we have different slopes, without even calculating anything, steeper slopes mean faster. So either faster in the positive direction, the green line, the top line on your screen is obviously faster than the red line, the bottom line, because it is steeper. The same would be true if they were headed in the negative direction. So a steeper going down would be faster than shallower going down. So without even calculating, you can tell me some stuff about graphs. And lastly, about distance time graphs, your last thing you need to know about graphs for this unit is that you can also tell a lot, once again, just by looking at the shape of the line. Any positive slope, any slope that looks like it's going uphill, so like from 0 to 5 seconds here, is moving forward, going in the positive direction. Any zero slope, no slope, or not moving from like 5 to 15 seconds, it stayed at distance 7 meters. That object stayed there. So that means that it's not moving. It's a zero velocity. And anything downwards, so like from 15 to 30 seconds there, is a moving